So, the physics stuff, we're actually going to do it today, okay? On top of that, we're going to play around with Git a little bit. So we got the repository set up the other day, and as David and I started looking at the editors that you submitted, it's pretty obvious that we're doing kind of normal things with Git, and there's a few kind of enhancements, shall we say, we want to make. And so there's some stuff that we're going to go through. I'm going to give you some plugins and tools that I use in my VS Code to make it easier. Our development editors are supposed to be integrated development editors, and that means we want to integrate all the tools we use so I can just kind of maximize my editor to one of the screens, and all the functions I need are right there. So we're going to give you an idea of some of the things we're going to do with that. So I'm going to start talking about some of the physics things, and from there we'll move on to kind of like building some of this stuff manually. The stuff I had at the beginning, that big white screen with all the scribbles on it, we're going to end up doing a bunch of diagrams and doodles today, which is probably what you're going to need to do to help get your brain straight on how this stuff works. If you break it down into small pieces, it's not that hard. If you allow yourself to try and consume the whole thing at once, you will get very confused. And this is just normal. This is designed to push you into a realm where you're going to build something and you're going to test it, you're going to make sure it works, and you're going to put it to the side and forget about how it works internally and just trust it. And the trust part is going to be particularly hard for all of you when that thing that you built and set to the side is built by somebody who's not you. And this is one of the first things we need to get over as junior programmers going out into game development teams, right? The number one complaint we get from senior developers is about people who don't understand how some piece of software works, so they rewrite it. Right? The hardest thing to do and the most valuable thing to do are the same thing, which is to trust that the work that's gone before you works, and to use it without knowing how it works. It's a really hard thing to do. Okay? And it starts by starting with small projects. In our physics component, the model component of what we're doing, we're going to use a bunch of library tools. The Box2D libraries have an elaborate set of documentation online that are all horrible, pathetic, useless in most respects. That's both a good thing and a bad thing. The good part is you kind of gotta just use what's there. The bad part is if something goes wrong, you can't really dive into it to figure out why. Okay? The documentation was written for the original library, which was done in ActionScript. For Flash. Okay, it's since been ported to multiple other languages. And because of the nature of the physics calculations that it's doing and the optimizations that it's trying to do, diving into the JavaScript behind it is just ugly. Not to mention, it's an old library, so it doesn't really adhere to the modern module-based ES 2022 or 2021 type JavaScript. So we got to coerce it a little bit. Okay? That's why I'm going to give you, or have given you, that physics library. If you looked at it, it's just a bunch of redirects, right? And we'll bring that up and we'll go through exactly what it's doing there. So we'll start with kind of the way we were going the other day. We're going to use Box2D to model our world. That means as we load our level, we got a bunch of information, most of which has to do with putting a div on the screen. Put it this top, this left, this width, this height, this background image, or this CSS class. Draw that thing there. The step that you need to do next is to add the model part. And that model part means that for every one of those divs, every one of those collidables, they need a rigid body that's attached to the Box 2D world. And the easiest way to do this is to build a collidable class in JavaScript. When you read that file from the server and you get handed back this weird object thing with an array of collidables, inside that array of collidables is a JavaScript object, an intrinsic object. That should be the parameter to your collidable class constructor. Okay? Because it has everything in there you need to build this collidable class. If you can build that collidable class and create a list of them, then your world can create a list of collidable entities. Which means every time we go through the game loop, we can simply tell every collidable entity to update itself. And fortunately, the way we do that is we tell the Box 2D world to process one step of the simulation. Right? Take all the forces on all the collidables into account and figure out all the new positions. And then we can walk through our list of collidable JavaScript objects, our controller objects, and ask each one of them to draw themselves, to render themselves. Because each one of them has all the information it needs to do that. It can inquire into the model as to where the model is. From the coordinates the model gives it, you can compute the coordinates that this new div should be at. And the easiest way to manipulate them is to use CSS transforms. So I'm going to show you how we do that. The reason I use CSS transforms more than anything else, rather than manipulating top and left, is the CSS transforms force the calculation onto the GPU, which lets me have more collidable things on the screen, which is just cooler, right? So it makes things run quicker. So knowing how the machine works and how JavaScript does things in the background, while we can't explicitly say, no, run this on the GPU, run this on the CPU, but knowing how it works, we can choose ways to implement things that make it more efficient. So we've got to build that world. We're going to build a world controller that has a world model and a world view. The world view is the DOM element of your whole level. The world controller is what we're writing. The world model is the Box 2D world. Okay. We're going to do the same thing with all the collidables. We're going to do the same thing when we build up all our individual targets that we're trying to get. We're going to do the same thing when we build something that we're going to shoot, a projectile. And in fact, in my demo app, I actually put them all on the same list. So the update render part just says, walk the list of all entities, all the collidables and all the little birds and all the projectiles, and simulate the next step of the simulation, and then re-render everything in its new position by changing its CSS transform. So there's a lot of repetition we're doing here. Okay? And we can break it down into some components. There's an opportunity, if you want to use some inheritance, to use some inheritance here. It doesn't really, in my opinion, buy you anything, but it doesn't mean it's wrong or bad. Okay? And we're rapidly getting into that place where there's 10 different ways to do this, and only 6 people in the room, and only 3 projects. Okay? And all 10 of them are perfectly valid. And you're going to run into this more and more and more. There isn't a right way to do this. There are multiple ways that will get the right result. Some ways are more efficient, some ways are more optimized, and some ways are easier to maintain. And I want to kind of steer you towards the more maintainable ones, right? The scalability thing, to me, is one of those key things that they don't really teach you in university even, right? How do I architect and design and build objects and classes and systems so that when I scale my team from 3 programmers to 30 programmers, things don't break and I'm not bottlenecked by just one person? And how do I make sure that everybody can contribute, not just a few select people? Okay. So we went through this a little bit the other day. Yeah, you are going to need some math. No, you're not going to need to do the heavy physics math. That's done directly by the Box2D library. They do provide some things for us that we're going to use, particularly points and vectors we're going to have to do something with. Now, at this point, I'll tell you that I like to build a point class at some point, and we'll try and do it in class today. And the reason is we have to deal with multiple coordinate systems, and the math behind it requires me to draw a picture every time, and I've done it before. And on paper, it sounds really simple and straightforward, and when I go to write the code, it always messes me up. So I do the doodle, I do the picture, I do the coordinate systems, I figure out the way the math works, and I write the math into an object. I make an object that represents a point in space in my game. And I allow that point object to do the translation for me between screen coordinates and model coordinates. And that way I can go either direction. It also lets me introduce a couple interesting new JavaScript things. We talked about this the other day. Everything model in the Box2D world is on meters, kilograms, and seconds. Of course, we don't have meters or kilograms in our JavaScript world, in our web development. That's all part of the model. But we have pixels. So we have to introduce a scale notion of pixels to meters. Seconds is one we do have, except in JavaScript, everything that has a timing in it will have that timing in milliseconds. Okay? So 1,000 units of thousands. We talked about this a little bit last time. We're going to have a scale factor on there. And then, like I said, we'll build a point that manages this coordinate translation. So here's the hard part. And it's not really crazy hard, and it's easy on paper, I think. When you go to write the code, it's very easy to get yourself confused. And so there's a couple tricks we can use to do it. You're going to have to decide for your team which way you want to be the default. In other words, do you want the screen coordinates to be the default? Or do you want the world coordinates to be the default? Okay. And you may change your mind on this. Really, what this comes down to is as you start, you choose one arbitrarily, you build a class to represent a point in space right here. You allow yourself to create a new point object that can say, hey, give me the as world coordinate, which gives you right here, right? Same place. But now it's got different coordinates because it's now negative in X and positive in Y. Whereas your web browser positive goes the opposite way and the origin's in a completely different spot. So you got to do that translation. And if you find that you're converting everything to world coordinates before you use it, well, maybe what you should do is flip your point class around to store everything in world coordinates and have the calculation do the screen coordinate. It doesn't matter which way. One way will be the default, the other way you'll do some math to figure it out. Okay? So then we got to build everything now from a main loop at the top end to that point at the bottom end, and we got to make those two come together in the middle. Okay. So structurally, we got that model view controller thing. We're going to start with an application. If you want, it's worthwhile, I think, sometimes building a UI component, a UI class that manages all the UI stuff. I typically build that into my application object. I said, you know, jQuery stuff goes here and pretty much nowhere else. And the only reason for that is if I need to switch from jQuery to something else, I go to one spot and I can find it. All right, let's get into some of the details. So we started with a little bit of this. that physics library we're going to open up. That physics library is just a bunch of shortcuts. See if I can open that on the side. Oh, it's going to open on that side. Would I get 2 of them? I do. Let's go and change this to this guy. Oh yeah. Okay, we'll bring that up in a sec. Maybe we'll make it now. Super Space Wars. Hang on. Okay. Let's get this go. Cool. So here's the stuff we did. Now, what I need to grab here is from Moodle. There's a physics object. Physics.js. Can you see it there? Okay. Take my download. So, here's this physics object I'm talking about. I think that's what it's called. Yes. Should look a little like this. Close enough. Let's there. When we start building some of this stuff, I'll just live share the screen, and you can see what we're doing. Okay, so we've got a couple things going on here. First of all, I'm loading my Box2D library, which is also in Moodle right there. That Box2D library, you click on the link and download it. You notice I created a common folder because I've got some stuff that might be common between the editor and the game. So just my own sanity. This is, entirely me. This is nothing you have to do. You can put it in the game if you want. Okay. I don't think my game has much in it right now. Index and main. I don't have a scripts folder, but I will. It's key to note that when we're building these applications and you look at the structure of it, from the main folder, the server's at the root. Whenever you run a server on the web, you can't see any files on the server above the current folder you're in. It's a security thing. Which means everything has to be at the same level as server.js or below it in terms of tree structure. And every HTML and JavaScript file has to refer to things with relative paths. No hard drive names, no double slashes, right? Unless it's an external URL, and even then you're just introducing dependencies. So for our Box2D library, we're going to load it locally. And what you'll see in this box2D physics file is really a bunch of synonyms. I mean, unless you really feel like typing box2d.collision.shapes.b2 mass data every time you need to set up some mass data or a new mass data object, I can just call physics.massData. And this is one of those nice things with JavaScript, is because everything is a reference, we can create our own names or references for things and map in the existing real-world reference. And by reference, if you're unclear, in C++ terms, every single variable in JavaScript is a pointer. They're all pointers. So when we manipulate stuff, like say something equals something, we're just saying their references or their addresses are the same. JavaScript takes care of if I change one of them to carve off new memory and change the pointers around and put the value in the right spot. It's kind of background stuff. But it means we can do some fancy manipulations. I have a really ugly API. I'm going to turn it into a clean API. Okay, we're going to use our physics to grab the gravity value. That's that 9.8 value. I'm going to create a vector 2D, with that value. Okay? And using that vector, I'm going to specify a new world telling it which way gravity is. If you make gravity 0 by 0, you have outer space. If you make gravity negative, things will float up instead of down. Gravity is a force pulling down. So you can create some interesting things. You can change gravity. You can't change gravity after you create the world.
Then you don't want to.
Okay? Because that's a whole new different world. So in the future, if you're building something and you think, hey, wow, this would be cool, but I want gravity to go sideways, like I want to flow through the fluid kind of idea, you could make gravity sideways, or you could make gravity neutral, 0, 0, and apply a force to all the new objects. So you'll get the same effect. 6 and 1, right? All right. This basic building block is how we build components or model objects. First of all, we need a position to put them at. The second thing is we need to create a body definition. Third thing is we're going to tell it what kind of body it is. And there's only two possibilities here. There's a constant called dynamic body and a constant called static body. Right? So which one does what? Right. Static doesn't move. Static is exactly where you place it. And they will never move. Doesn't pay attention to a lot of the physics counts. Dynamic bodies move. Okay. We're going to specify its position. Then we're going to create this rigid body. Now that creates a rigid body. And we can grab that rigid body that it creates because we probably want to hang on to it. We want to hang on to it in our controller, so I might make it this dot model, right? When I build my actual controller, I want to hang on to it because I'm going to need to interrogate it every update. Every time I re-render this thing, I got to go ask that model, where are you now? And more crazily, how are you rotated? Okay. We talked about that stuff. We've got to build a couple other things. We've got to build these fixtures and the shapes. The shapes help us with collision. And I've told you before, use the recommended kind of like static shapes. Circles, boxes, and triangles. They just work, okay? And most things you can represent with those three shapes. Technically, you can do whatever polygon you want. But you have to ask yourself whether it adds value. Right? And this is the first part where you want to start thinking the way game engines think. what we're using in software to figure out the collisions might be very much simpler than what we use to render. If you translate this into 3D, what I mean is I might represent the entire collision with an entire character with a sphere. Because spheres are really easy. They have one value, a radius. So it's really easy to figure out what's around it. And only if two things collide, in other words, the two spheres intersect, do I need to get more detailed about what parts of them intersected. Whereas the render geometry might be 10,000 polygons in a very elaborate, detailed shape. That's a very expensive collision to try and detect. Okay? So the physics model of our world is almost always a much simpler representation of what we graphically see on the screen. This is true in Unreal and Unity as well. We also need to build our components up. We have a world. We're going to add our rigid bodies to the world. The rigid bodies all have fixtures attached to them to give us those extra parameters. How bouncy is it? How slippery is it? How dense is it? The density is combined with the shape to give you mass. Right? So I can have two things. I can decide that, you know, I have a fixture for stone and I have a fixture for ice and a fixture for steel. But they don't tell me anything about how heavy something is. That's its mass. So a steel ball bearing is not going to be as massive as a steel basketball. Okay? So the shape combined with the density gives us our mass. The rigid body uses the mass to figure out what forces are applying to it and update its position and its rotation. And the world handles the interactions between all of them, and all of what's inside those things, all the guts of those things, is hidden from you. Right? Has anyone looked at that Box 2D library? Old JavaScript. How weird is that? There's the definition of Box 2D inside that thing. You're never going to write these. Never going to make you write these things. If you ever come across them in a library, what they're called is a closure, or an immediately invoked function execution, IIFE. I'm defining an anonymous function with a couple parameters that has some body and immediately gets executed, which means it returns something right away. Now this was done back in the old days because all variables were scoped to a function, which means you could see any variable anywhere within a function or any sub-function. So by doing this, what you're doing is you're taking all the variables defined inside here and making them all local to this function. They can't be seen from outside. It's effectively giving you private things. Okay. On top of that, there's a whole bunch of extra definitions. And a lot of this stuff is about, hey, if this didn't work, define it to be the empty object. Right? So they're like overrides in case things are broken. And then there's a collection of those. And that's not the minified version, that's just the wide open. Okay. It also means if you're ever in the debugger and you go down into the Box 2D stuff, just immediately step up and out. because you're not going to learn anything from diving through that code.
Just custom.
Yeah.
So
Okay.
I have a folder called common with physics and the box video library.
Yeah. So you need both of those things. We'll import the physics. The physics imports the box 2D. Okay. All right. So the last piece of the puzzle is going to be, how do we make things move? So as the application starts, you choose a level, you load the level. When you load the level, it creates the list of all the rigid bodies in the system, attaches them to the world, and tells the world, go. At which point there's only one force on things, gravity, and things fall. And then what? It's not much of a game. Okay? So the next part is just like pure normal old JavaScript. Design something that looks like a big button. Or do the golf swing thing if you want to try that. Right? You know the golf swing mechanic? Where you push the button once and you watch the meter spin across, and there's like a little line 2/3 of the way across, and you want to bounce it off the end and come back to where the line is. The closer you are to the line, the stronger the shot is. Right? So I've seen that done with other student assignments. I've seen people do wherever the mouse is pointing, just following the mouse move messages. So they aim the cannon at the mouse. That's kind of cool, and then click the button to fire. Right? I've seen guys use a slider to set the strength, and then follow the mouse and click the button to fire, and it shoots at a certain strength wherever the mouse is. Right? I've seen people use the arrow keys to change the strength. I use the arrow keys to aim the cannon, and I have an actual button on screen. And don't be afraid to implement something just to get it working that you plan on ripping out later. Those debug tools, if it makes your life faster and easier, do it. Okay? The code is cheap. The code is going to come and go. You're going to write stuff, you're going to rewrite it, you're going to learn something new, you're going to throw away 3 weeks worth of work and write it again. The code is not worth what's in your head. Okay? So, once we have all of these rigid bodies, we're going to have to apply some forces to them. And the way I put mine together is I created an extra rigid body called a projectile. I stacked it in Z order and put it behind my cannon. Right? I keep track of the cannon's angle, and whenever you push the fire button, I create an impulse in the direction, create an impulse vector in the direction of the cannon, and apply it to that hidden object. And then I ignore it. I let the physics engine do its thing. Okay? So we'll kind of start from the beginning and roll through some of that. Now, you can apply additional forces if you want. Okay? Like, I might take all of those targets, all the little birds I have flapping around, and they just have a CSS animation on them. And I might, in fact, attach a force to them up, so they're trying to fly away. The other thing we're going to have to take care of, part of making a game, is visually I'm going to see a div with a nice image for my background image. But from a physics perspective, the world doesn't really have a bottom. So we're going to need to put in some static bodies that are fixed, like a floor, so that things stop when they hit the floor. And we're going to need to put in probably some walls. And if you don't put a top on it, the birds can fly away, or whatever the target is can fly away. But the balls or the projectiles can also bounce out. So that might or might not be a desirable thing to deal with. And that's entirely up to your game, how you want to implement that. Let's take a look at how some of this fits together in terms of actually putting some of the software in place. So, first thing I'm going to do here kill that. Bring this guy back. Let's just share it. Sure, okay. I'm going to throw this in the text channel in Discord. Go should make things a little bit easier. Let's see you guys all line up there. All right. So first, a little bit of tooling. Built into VS Code is our source control. Okay? So when do we commit changes to our source control? Every time you have something you can't afford to lose. If that's twice a day, that's twice a day. If it's 45 times a day, it's 45 times a day. Right? If you want to see what's going on with the source control, you don't want to bring up source tree all the time. I have a plugin I tend to use, and the plugin is the Git graph. Okay, and I'll show you what the Git graph does. It ties into the source control tab, and it's this little icon here. And the Git graph gives me a picture of my repo. Yay. So I got to use both of them. This, I've got origin, which is what's in the cloud. Here's my main. Here's my develop branch. Okay. And the theory here is that main is always working. Develop is my work in progress. And if my work in progress is in any way going to be experimental or dangerous, I can fork off other branches to do that. The hardest part getting used to is that Git is going to overwrite the files in the folder you're in. It will not clobber things you've changed. In fact, it will prevent you from pulling out the latest, greatest stuff. But if I want to get the latest, greatest stuff, I'm going to go to my Git repository here and pull them from the cloud. And hopefully it won't give any error messages. Hey, okay. So the one that's in bold is where I currently am at. And if I want to take a look here, I can take a look at what this guy did. This guy has these 3 objects. And I can see that this one added 4 lines and removed 4 lines. And I can click on it and see what I did. Exactly what I did. So I don't have to remember what I did. I have a tool that does it for me across as many files as you can imagine. Okay. If I want to get it, I can just double click it. Yeah, I want to check out that branch. Here's a bunch of files that have changed. They would be overwritten. Are you okay with that? Well, it gave me an error and said, no, I can't check. I can't do it. It won't let you overwrite files that have changed. So you won't lose your changes. So how do I save them? Well, I'm still in my develop branch. I'm going to take this develop branch and I'm going to hit that plus sign and stage all of these changes. And then I'm going to take those staged changes and I'm going to commit them or save them. Now the reason I put a reasonable message in there is that when I look at this history again, the only thing I get are these messages. Okay? If something goes wrong, how do I know where to back up to? Well, if I want to back up to this guy, I'm going to read this, right? Which is why we want small atomic commits. One feature, one commit, right? By doing that, if a feature goes haywire, you can undo it. If a commit has 6 different features in it, or like a whole day's work, or heaven forbid, a whole project's work, you have 2 options. You have the broken one, you have the initial one that does nothing. Those are the only 2 steps you got. So the more granular you make these commits, the easier it is to back out of bad things. And I guarantee by now you've already all hit that one place. You know that place where you've been working on something for a few hours and you realize you're on a dead end, it's not working, and you just want to go back to where you started from that session, right? Me too, I've done it. Okay, the difference is, as a pro, it takes me less than 30 seconds. I don't have to remember what I did. I don't have to remember what it was like when it last worked. I don't have to go search folders on my hard drive to find it. I go, hey, that one worked. Let's go grab that one. Check out that. And I'm back. Okay. If I'm even smarter, what I'll do is I'll commit my changes to a branch that I never merge back into that develop branch. It's all stuck over there. I've saved it. All of these things happen in the same folder. And we'll illustrate that in a sec. So I've got these changes. I've committed these changes. If I push sync changes, it will take my changes and push them up to the cloud. Okay? Which is exactly the same as going here and going push.
What's the difference between commit and commit stage and all?
So when you commit, it commits everything that's changed. When you stage them first, you cherry pick what you want. So typically, you'll work on a bunch of things and end up touching 6 files. And then realize that these 2 files over here that you touched were because you found a bug and you fixed it while you were there. But they're not part of the feature. So I take the 4 files, I stage them, and commit them. I can make 5 commits before I push to the cloud. I don't have to push every time I commit. And in this case, I'm not. I'm going to flip back. You can see my develop branch is now a work in progress. And I can look here and I can see these prefab target, prefab info box, prefab collidable things. When I look back at my actual source, the editor folder is empty. I'm not on this origin new render branch. I'm on the develop branch. So what happens when I check this out? That went away. How come the whole Git thing closed? Right?
Live share also crashed.
It's because the folder went away. Because the folder wasn't part of that commit. No folder open. And now the editor's all there. Right. Live share back up. Throw another link up there. There we go. You notice it did all that overwriting all in the same folder. It just set the current folder to be whatever version I choose here. Right. Think about how much disk space this saves. Or confusion, right? 11 o'clock at night, which folder do I zip? Oh, I don't want to zip it. That's just wasteful. I don't ever want to put a zip archive inside Git either, because that's just, what, a binary file that's out of date the moment I put it in there. This is why we have some configuration elements on our Git repos. We don't want to put any files in there that we generate. Because the moment we regenerate the program, it's like when you use C# or C++, there's an object folder that gets created with all the temporary OBJ files, right? All the intermediate object files. There's an intermediate folder sometimes that gets created. We don't ever put that stuff in source control. Because the moment you change one character and recompile it, those things are all obsolete. So you're just chewing up disk space for no particular reason, because it'll never be something you can use. So it's just source code, source control. Now, the reason I'm going at length at this is that with two of you working on every project, you're consistently going to be edit something, make it work, commit it, yell across to my buddy, hey, there's a new point object, you should go grab it, which is more common than you think in most programming environments, right? Hey, there's a new world object, I fixed a couple bugs we had in it, go grab it. And your responsibility at that point is to do a pull from the cloud. And that pull from the cloud will merge the cloud code into your code on your machine. When it does so, if it can't figure it out, and it's pretty smart about stitching code together, but if it can't figure it out, it'll complain and give you what we call a merge conflict. And the way you'll see that in the file is you'll see like a bunch of greater than signs listed by a version number. You'll see your chunk of code. You'll see a bunch of equal signs. Then you'll see the old version of code and a bunch of less than signs in the version. And your job there is to choose and or edit down into something that works. So you got to test it again before you commit it again. Right? Don't try and commit things with merge conflicts. Your teammates really hate having to fix your bugs and your problems because you didn't test things. All right, I'm going back to develop. It's going to drop me again. Yes. So, what we've learned is that the source control integration and live share do not like each other. Stop it. Okay. Go link to the latest one. There's like 4 links in Discord now. Top down, let's build this whole thing. We can frame it in pretty quick here. Let's just take a look at main to start with. And we'll just kind of use our top-down design, right? Now, you don't have to use this private thing. I'm just trying to show you an option. You don't have to use private variables at all. In fact, if I don't use this at all, I'm just going to have some properties for that game application. And when I go to update things, really, I'm just going to like update everything. Let's call it render. Okay. We're going to break these down a little bit more, but I'm going to start by just framing in kind of the comments here as we go. Now, when we run our application, what are we going to do?
Create a word. Oh, yes.
That does one frame, right?
Oh, it's okay.
One frame, so to speak. And then we'll use request animation frame. And it takes one parameter, a callback. And I'm going to do this recursively. And what am I going to call? Now, I'm making the assumption that request animation frame is going to do what I think it's going to do, which is it's going to figure out how much time elapsed since the last request animation frame and tell me. And long term, I might want to use that to figure out how much I simulate. And it's JavaScript so I don't even have to have a parameter on the method, it'll just ignore it. But for completeness sake, I'm just going to propagate it all the way through. Now, if I run this, is it going to work? How will I know? How will I know? Well, let's just throw a counter in there. Use my little backticks here. Easy peasy, right? I mean, the whole thing fits on screen. I don't have to scroll anything. How do I test it? How do I run it? I want to use the server to run it. So first thing is the server going to handle the root? Well, I've got this use statement in here. And with Node Express on the server side, each use statement maps an edge in the URL to what to do with it. And in particular, this edge I have mapped to my game folder. So it's going to look for index.html in my game folder and serve that. And in fact, all static files, all files requested with a GET request from the browser itself, not from our JavaScript code, will go and get routed into this edge. So this is kind of redundant, right? I can actually get rid of that. And I don't have a test folder. Now the constructor for the server is really kind of nice and short and neat. Okay. So now what do I want to do? I want to have a node target to run. I'm going to go to my package.json, which I don't have here. Is that in the editor? Oh no, I don't have the editor here. Let's copy that editor over. There's my editor. Okay, oops, put it in the wrong spot. So there's my editor. And what else did I have in there? Just catching up with you guys a little bit. So inside the editor, I had that package.json, package-lock.json. I'm going to put them in the root because that's where my server is. Set in the root. Okay. And I'm going to change this to and then what I'm going to do is I'm going to add a script. Now I'm not doing anything different there, but I'm setting myself up so that if I want to do something different, I can. That's all I really need to go for. This has got name of the package. There we go. Now I'm going to run it. I'm going to choose run and debug. Okay. I'm going to show the automatic configurations into node.js, and it looks in my package.json file, and I pick that one. It literally starts running it and tells me all my errors, right? So let's fix that up, and then we'll take a break. Cannot find package fs extra. Let's add another terminal. It's just going through the dependencies in package.json and trying to figure out what's there and what's not. And can't find cores config. That's my problem. New cores config. config. So let's go back here. Of course. Ah. It's this thing. That object goes there. I'll explain what this all is in a sec. Guy. What else are we missing? Can't find package cores. Probably have to add path and URL as well, right? I'll do that when I show you which one's mixing now? Requires a middleware function. Path. Just adding all the right pieces. If in doubt, you can just add, just npm install the things that are listed there in the main server. What is CORS? CORS is the Cross Origin Restriction Service. So basically, when you connect from a client to a server, the domain name has to be the same. localhost to localhost,
Oh, yeah.
mysite.com to mysite.com.
It's talking to each other.
Right. So without the cores part, if the domain name's the same, everything will work fine. Okay. If you ever want to build a server that you want other people from other domains to be able to access via an API, for instance, then you need to install the cross-origin domain module, and you need to configure it so that it allows all content type. This one in particular, I allow get and post and the hidden options method, but I don't allow put or delete messages. I will take any origin, any URL whatsoever, because I just don't like security. And pre-flight continue says after you send an options request, it's okay to keep on going and send me the next request. Essentially, the handshake behind the scenes when you do a post from your JavaScript client is it sends two messages. It sends an options message to the server to say, hey, what am I allowed to do? Followed by, if you're allowed to, the post message. So this here allows me to send options and post from a domain different from where the server is running. Is that a really convoluted way to do something? Okay. And then on top of that, it also has, is this running yet? No. Path URL. Don't really even need that right there. What's the one that's missing here? It's all cool. Let's put the breakpoint in. Ah. Let's break it. Line 4114 is the core's header. I think I can just take it out. Sure. All of that work. If I'm doing this for a bigger server, I'll take this part and I'll take this callback function and I'll make an object out of it. And then I'll just have the object have a couple methods that return these things.
We should add those ones.
You know what? I've just removed it completely, so you don't have to add them at all.
Okay.
As long as you go from localhost to localhost, it'll be fine. Okay. At this point, it's not significant. I just thought I would introduce you to the idea. I'll clean it up and share it. But I mean, when we're all done this, I'm going to give you a template. Right? As we go into further and further, more complicated apps, I don't write this stuff from scratch all the time. I clone a template, copy it into another folder, rename a bunch of stuff, and start from the template. Just to make life easier. Let's take a short break, just like 10 minutes here. And when we come back, we're going to start to work on the client side because I'm less worried about the server side. I just want the server side so it will serve the client files. All right. The server is your working server from the previous assignment. Okay. So, have a drink, and we'll start talking about, let's fill in the blanks. I'm going to leave the server running while it's doing this so I can go. Now, the server is on the node monitor, which means if I touch the server will restart. That won't force the client to restart. And if I'm working on the client and I'm not doing anything with the server, I'm not loading a level or anything, I can just run the live server and just run the client, just dummy out the data. So what we're going to look at doing is how do we build these things up, starting from our common kind of core idea that what we really want to do is we want to put stubs in so we have a running program all the time. Okay? So the way we start with that is when we start building, we're going to put everything in a comment, and I'm going to prefix them all with to do. Okay? So I'm going to initialize the app behind a splash screen. And you just write this stuff in English just so you keep straight what you need to do. And then what I'm going to do is choose a level. Load level and generate world. Run the simulation. Kind of what I'm proposing. I'm going to need to track a few things to do this initialization. Let's start with the view. And what is this view going to be? Well, this is my game area. Game screen. Game area. So let's just call it game area. Not that guy. There, I'm just going to grab that jQuery object that represents that whole game area. Now I have access to it whenever I need it. And I'm going to need a world. And I'm just going to throw a dummy object in there for now. Right? And that world is going to be a world controller. Right? Now, where you go from here, it's kind of up to you. There's a lot of different ways to think about this. You know, I could have the application or the game here have a list of all the physics things that are going on. Or I could have the world have that list. You guys have a preference? Do you care? What would be cleaner? Having the world have the list? I mean, I'm going to attach them to the world anyways, right? What about initializing the splash screen? Right? Does it do anything? No. So I'm just going to fill the whole thing in with comments. Always running. Always be running. Right? What about choose a level? Now what's the problem with me just throwing that in there right now? Kind of the whole splash screen thing has to wait till the splash screen finishes, right? Am I going to worry about that right now? No. That's the name I'm going to eventually pass to the server. You notice I'm just going to hard code it. And I'm just going to carry on doing this. I'm going to remove the to-dos as I go. Why do I put the to-do part in there? Has anyone played with Visual Studio's tasks? I have a plugin I had to add to do the to-do tasks. There's a to-do plus plugin for VS Code as well, and it goes and searches for the keyword to-do everywhere in your workspace. And it gives you a list of them. When all the to-dos are gone, I'm finished. So if I just top down, do this, do this, do this, do this. How do I do that? I don't know, but I'm going to make a method for each one and fill it in with a comment, with a to-do comment. And then, when it's time to go into main, it says load level and generate world, goes there. How about initialize the splash screen? And then I write a little bit of code to initialize the splash screen. And then I remove to do. Okay? I have a couple things. Enable the edit buttons. I still haven't finished that. Ooh. How did I remember? Right? It takes me right there. I forgot to do something. When you have 10,000 files in your project, these tools become really, really helpful. So the tools help. Let the tools do what the tools do. I even threw a to-do inside here. Actually, it may not even be me. Something somebody left behind. So we're just going to carry on and put all these pieces together, right? I'm sure you can already see where this is going, connecting these two methods. Isn't that what I'm going to do? Right. I don't know how I'm going to do it yet. I don't have to decide right now, do I? You going to make me decide right now? So that's part of why we write the comments first. You can write everything top down. The whole thing's still working. Counting away. Doesn't really show me anything because I haven't got all the CSS in place, but I'm starting to get the entire application framed up without. Okay, and it's working right now. So what better time to go here and put this into my source control system, right? Let's go take a look. Let me see where we're at. What's the magic here? Come on. Am I reading that wrong? No, I am. There we go. Look at that. I've got your cowboys and aliens stuff here. Right? So I'm gonna change my my thing up, but this would be the place where I would go and I would start carving off commits. So at this point, I would probably grab the main game, the game CSS. That's one commit, because I've stubbed out the whole game. I would put all the styles in another commit, so that they're all linked together. Those are the common styles. I take the library stuff, so jQuery and maybe jQuery here, and I would put those in another commit. I would take the package stuff and put that in another commit. I would take the server and put that in another commit. I would take the editor stuff and put that in another commit. So it's like 4 or 5 commits there. I wouldn't push them yet. I would just stage and commit them as different commits. That gives me fallback points, different pieces I can cherry pick out of that. I'm going to change it away from your repo before I push anything else there. So what else do we got to do? I mean, this looks pretty straightforward, right? But it doesn't do anything. So the first thing we probably want to do is initialize our world. So let's just create that. Underneath the game, underneath scripts, I'm going to create a new file. World.js. Right? And in the typical way, I'm going to stub it all out. I'm going to make sure this works by going back to main and importing my world. Relative paths. Now here, I'll attach a new world. Still runs. Still runs. Right? And what does the world have to do? Set up a view and model, right? Connect to those things. We probably have some default parameters. Properties. And then create walls and floor maybe. And here's one that you may or may not be thinking about is how do I detect collision so I can do something? So in the future, we'll do that. And there's a couple other methods that I'm going to add to my world as well. Now that doesn't mean those are the only methods we're going to have. We'll probably have to add some more to go. But you notice I'm still in a working state. I'm never not working. Right? I don't necessarily know how to do all of these things. Some of them I'm going to have to look up. Some of them I'm going to have to watch some video again. Some of them I'm going to have to read through some slides or look at someone else's stuff. But I'm working. I'm always running. Right? Always in a running state. So let's take a look at a couple of these things, and we'll add some box 2D stuff for the beginning. Okay. The first thing is I'm going to set up the view model and properties. And where am I getting this view from? Let's write dry code, right? We're not going to repeat ourselves. And I want the controllers to know as little about jQuery as possible. So if I have to go update jQuery, I don't have to do it here, right? Now, of course, like good programmers, you would probably put defaults in for all of these parameters. So if I look back at my world, I've got level 1 here. Okay, I would probably, level name has a default, right? An empty string. Or by default we load level 1. So if you just go choose level and you don't give it a parameter, it loads level 1. Now the same way that we do this top-down way of building all the comments first and then making methods that do nothing but they work, and then we start filling in the blanks, we can also push data down. As soon as I take this, hey, this is the way I want to call it. I want to give it the level name. But really, I should have a default level name. So if I call this with no level name, it at least does something intelligent. So I've taken that data and I'm pushing it down into the next layer of the software. Okay. And if you want to use the JavaScript private methods with the hashtag in front of them for some of these, feel free. It doesn't make much difference. If you're getting used to doing this in C#, just because people do it by convention, you can do it here. That doesn't make it private, but people will kind of understand. In JavaScript, it's the hashtag that makes it private. And of course, you would have to propagate it here as well. And if you think that looks ugly, just don't do it. And magic still happens, right? Still works. Everything still runs. So you're always in that running state. Okay. Let's keep going. I'm going to hand that view in. The world is going to build a world model as well. And how is it going to build that world model? Well, here's where we're going to import our physics thing. And probably doesn't need to be in the common area, but we're going to import and again, relative paths. Got to go up, up, common, lives, physics.js. Right? Here, I'm going to build a new physics dot what? And what does physics world take as a parameter? Well, here's where things get interesting. It takes a vector. So you just write it the way you want to read it first. I have to define that. And what's the gravity vector? I'm going to use a physics thing again. Vector 2. Now, the second parameter in Box2D's world creation thing tells it to make it alive right away. Okay. Model and view, we are the controller. I can now ask this.model to execute any physics world methods that happen to be out there. Okay. And again, it should still be running the whole time. Okay, so I'm not running. How come I can't find this guy? right? In physics.js line 14. That's where it's dropping. Think it's got any issues with that? Right. Why can't it find it? This is one of those weird things. This is where we might have to go back to the server. The server here lists where it's finding all these files. And it's got the common folder there, but it doesn't have common lives. So I'm going to see if we can't coerce it. I think this is looking for the common/lives. Like this is just looking in the common folder. So I can do it two ways. I can either fix the server up, let that reload. Slowly. There we go. Is that going to work? Still not finding it. Well, if I'm not going to do that, then I'll do it in the client. I want that load. Why won't that load? Cause that's why. You see it? See the name of this file it's trying to load? .min.js. And then come over here. Where's that box2d web.min.js? There wasn't one there. So my mistake. Your box2d, yeah, the one 2D looks like this, right? Yeah. So that's what we call minified. Because everything gets passed as text in JavaScript and the web, how do you protect your source code? How do you keep somebody from just copying your source code? So there's tools that will take a JavaScript file and do what we call minification. And what they do is they take out all the white space, all the tabs, all the spaces, all the indentation, all the blank spaces. They take out all the character turns and line feeds, and then they start renaming all the variables with single character variable names. The first variable it encounters becomes A, and the next one becomes B, and the next one becomes C. So if you look at the minified version, you get this. This is jQuery. You'll notice the parameter names are no longer well defined. They're just letters. You can try and, prettify it up with a formatter, but it doesn't help you that much figuring out what's going on. I mean, especially if this thing gets big. Do you want to try and figure out what that is? Right? Well, neither do I. So, there's the minified version of Box2D. And my physics.js was looking for the minified version, and I never copied the minified version over. I copied the unminified version over. So let's go reload it. And my errors are gone. So that gets to that next point. Not only are we always in a running state, but as soon as we have an error that prevents us from running, we stop everything until we fix that error. And just as a philosophy, it means you don't end up with 10 errors that stick around forever, but you never see them because you never correct the first one. So if you just correct them as you find them, as painful as that is sometimes, you'll prevent yourself from spending lots and lots of time later trying to track down bugs that have been there forever. All right. So we got a world. Cool. Now comes the hardest part of all. Create the walls. So what do we have to do to create the walls?
Create static objects. Quadrant of the thing. Not quadrant.
Yeah. Spell right. Right? Now, when I go to do this, I'm going to create one. And we're going to take a look at whether or not we can make this nice and easy. Okay? The first thing I need is I need to know for the floor its position. So and I'm going to do this. Let's rename a couple things. I want to call this create wall. Change things around here. Which means create walls is a bad name, so I'm going to call create boundaries. Just like that. So, in order to create a wall, I need to know where it is, right? I need to know how big it is. Delta X, delta Y. And I think that's all I need, unless I want to put any additional kind of debugging info in there. the whole reason I wanted to do this is let's do it this way. I want to create a bunch of different walls, right? So how do I figure out that XY position? Again, these create walls are going to be model things. When we create these model things, I gotta create some box 2D stuff to do it. And the general idea here is, remember, we gotta have a fixture, we gotta have a rigid body, and we gotta have a shape. So, create the rigid body, create the fixture, create the shape, okay? We're going to assume that we can compute these somehow. We're going to put them at some location. So the floor, for instance, let's see if we can go steal something from my editor. Use that one. And I did something smart with game size. Right? Cool. All right, our XYs aren't defined. So let's give them some defaults. Remember, our origin's in the center. Right? Yeah. That's why we got this here, right? What would be really cool is if we had a way to specify these locations with an XY, some sort of class that we could use that represented a coordinate in space. Right? Now, don't worry, I'm going to put this in another file in a second. Okay? But specifically, what I want to know is, do you want to save the world components? You want to say the world coordinates or the screen coordinates? Well, right now we need the world coordinates. Okay. Not too hard, is it? Okay. Now I'm going to take this whole thing . Where's my refactor? Let's just do this. Refactor. I'll just right click on what I've selected. Convert default export to name. No, move to a new file. Now I've got this point file. That's built into VS Code. And then I need to import it here so I can use it. Just select it. I just selected a chunk of stuff, and then I right-clicked on the background and went to refactor. Yeah. So now I can go, well, the floor, right? Let's make it a variable. X and Y, 0. Okay, but in X, it's not 0, right? It's negative something. If I mark it at the 0. Or I could pretend I shifted down. Right? And then Y would be in the middle. So I kind of need my screen width and divided by 2. Don't want to do that every time, do I? And I want this in world coordinates. I'm going to come up here. And how do I get the screen width? Right? And if I'm not sure what that method is, I know that's a jQuery object. So I can always come here and go, is there a jQuery width method? Oh, look, there is. So you just look it up as you need it. And if there's a width method, who wants to make a bet there's a height method? Okay, and now I'm going to scramble your brain. If I'm just going to keep the width and the height, that's the same as a point, right? Like I can use my point class for this, but wait, we said we're going to store the defaults as world coordinates. So now I got to do something. Or I could store it as screen coordinates and convert to world coordinates inside the point class. Again, you can go either way. And what do we do? What's the x? It's this dot x. Physics. You notice it automatically stuck the import in there. If you look at that physics object, it actually has a world scale built into it. Pixels per meter. That's our conversion factor. And in the x direction, right, this is where we got to draw a picture. This is where we got to draw a picture. The glow burning yet? So when we're talking about drawing this picture, I've got my screen and I've got box 2D. Okay? So I got that world scale in there, and now I have to figure out, okay, in my game screen, what does this position work out to in box 2D coordinates? Because that's the as world coordinate version. So I got to take that top position, divide by 20, that's my world, right? That's the y. Plus I got to do something for that offset. And for the left position, I want to do the same thing, but I got to deal with an offset of a different kind. For the left position, it's pretty easy.
So the same like direct.
You want to grab a piece of paper and scribble out what the formula should be to turn a screen coordinate into a world coordinate. My suggestion is draw it out for yourselves, and when you draw it out, do 1, 2, 3, 4 points all around the compass, and make sure your formula works in all 4 of them. Just pick some arbitrary numbers. You know, this is 200, 200, right? Well, it's definitely not 200, 200 over here. We have to divide by 20, so it's 10. Well, 10, 10 would be here, right? So we want it over here. So it's minus 10 in the x. But how do we get that to happen? We got to subtract half of the width. Right? Because it works out to 10, 10, and I want minus 10, 10, and this whole thing is 20. And does that make any sense at all? Do you following? Am I going too fast?
I got everything.
Yes, I'm going too fast.
A little bit. We need to go back. Don't have much to go. And the top's gonna be big enough.
Okay. Converting to screen space. I got to multiply. And just think of the x in the first. That's the left position. You know, if I'm 10 units to the left of center, what do I need to do? I need to multiply by the scale, which is 20. So I'm now 200 units to the right of center. So I need to find out how far left is the center. So I need the total screen width, right, divided by 2 to add 2, right? So we need to add Does that make sense? Is that one okay? Half of the total screen width. And the y is a little bit different. I have to multiply by the scale. But this time, I gotta flip it around. So if I'm 10 units up from the origin, I want to figure out how far from the top I am. So if I'm 10 units up from the origin, I want to take the total height and subtract my height plus half of the height. Yeah. Right? So I need the total screen height. I need half of that. Right? And then I need to subtract it's just weird. It's just weird. So what happens if on the world, this is why I say you do it, where's that? There we go. This is why I say, so if I'm here at x is plus 10 and y is minus 10, okay, so y at minus 10 times the scale, minus 200, take half of this, minus 200, right? So half of this minus 200. Is that right? This would be minus 200.
Sorry.
To draw the picture. Okay. So when I take half, subtract minus 200, minus negative 200. Right? Remember adding it. So it's added 200, right? I'm dragging you back to like grade 10, grade 11 math here. Right? Take a number, subtract, a negative number is really adding them together. Okay. So that's what I say. To test this out, draw yourself a picture, draw a point in each quadrant, do the formula the way you think it should work, test it on those 4 sample points. If it works, code it. Okay? There's a couple things that I might do here. I look at this and I'm like, well, I just threw some variable names in there, which obviously aren't defined yet, but it looks like I'm going to be doing this calculation a lot. So couldn't I just do it ahead of time? Like the total screen height is always going to be the same. Right. So maybe I can just say, well, what's the total screen height? Let's just set it up. What did we say the screen height was? This is why it's good to fix them. What was it in Moodle? 720. And the width is 1280. Is that it? Now we can just kind of go. I'm doing this all as constants. And now I have those half height, half width. So total screen height over 2, this is actually just half dot height. And if I change the dimensions of my screen, I can come here and just change the coordinates. If I wanted to be crazy, I could do all sorts of other fun things, like maybe I don't want to create points with a constructor all the time. Maybe I want to create points with the screen width and height. And then have a method that sets the X and Y. You know, I could create a, say, this would go the other way, right? The opposite function. So we're storing everything as world space. As screen gives us screen coordinates. From screen lets me reset X and Y based on 2 screen coordinates. And the thing I do when I'm doing screen and world coordinate stuff is I name them so that I can clearly see the difference, instead of having to like actually think about it. So I might do something like this. Right? I always refer to screen coordinates as top left and world coordinates as X, Y. And it just helps me keep it straight in my head. So just naming things appropriately can really help us. Okay. A couple other things we can show you. Nice to haves. Getters and setters work really well here, by the way. And does this provide a ton of value? No, it's just consistency. But I could do that, right? That's just magically going to work. And then I can use it. Because I don't want to repeat myself. I don't want to write the formula in multiple places. Now I can have my cake and eat it too. I can either create a new point called P and go P.x or P.y or P.left or P.top and I get the right thing. Or I can go P.as_screen and I get an object back which has an X and a Y component in it. Or I can say P.from_screen top left and it resets it. Then I can keep going with the point. We come back and we use our point. And now we start to see, well, really what I want to do is say the max screen height. Right? And I kind of buried that inside the point object. Really, I kind of want something more global than that. So what I might do here actually, let's just use it. Create a dummy one. And what's the top going to be? How far from the top is it? It's going to be the screen height. And the middle. And then this is just right? Now how do I get the deltas? I can use a point again. Again, world coordinates, so maybe I just make up something here, but I could just as easily go 0, 0. Actually, I don't have to put those in at all, right? Did I make a... Yeah. So now I make the deltas, and I could go delta dot from screen, and now I can just put some numbers in. Hey, I want that screen to be 10 pixels tall, and this dot screen width wide, because it's the floor. Right? So here, I'm using that point object to access because it does all the calculations for me between screen and world coordinates, and once I have it tested and proven and it works, I don't need to think about it. I'm just going to assume it works. Well, imagine one of your teammates is building the point object and the other one is building this create boundaries. Are you going to hear about it if the point object doesn't work? Pretty fast. You built me crap. Get with the program. Fix your stuff. Right? Debug it. Test it. Make it work. Do some test cases. Write a little piece of code that's a debug method that just runs and generates a bunch of points. So you can put the debugger and look at the coordinates that it generates. Okay. So from here, we can figure out how we might make each of these walls, right? I can also, at this point, make sure that my game doesn't crash by just cloning these. So I'm going to get 4 walls, one on top of each other. Well, that's okay for now. What do we have to do when we create that wall? We need to create the rigid body. So, the first thing we got to do is generate a body definition. body definition. Now these are really weird functions. They don't take any parameters. Those are kind of like constants. It's effectively like doing this. Okay. Should see if that works. Let's see if I broke it. Cool. Okay, let's find our point object. Point. Can't find that. Me. Ah. Maybe we should load the right things. Ah. I'm not using the physics. I'm not using physics at all here. The auto insert, auto complete thing doesn't put the .js on the end. And then world, why is physics not defined? Now, why did that mess up? Yeah, you can't have them both be the same name. So let's just clean that up. So externally, they're X and Y. So we can't find my background, big deal. So now we have a world and our little point. We're creating a boundary. We're creating a physics body definition. We have to set the type. Crazy stuff. You know what? There's no real easy way to look this stuff up. So I will point you at this guy. There's a bunch of samples. I have a tells you how all of Box 2D works. But it doesn't really have a nice, like I said, documentation is like digging for stuff. We got to create a fixture. So I'm going to create the definitions first. Fixture definition. Numbers. Restitution. Gotta spell that one right. So the density just makes it really heavy based on the size of it. The restitution is really small, so that means it's not very bouncy. Okay, so 1 is like a rubber ball, and 0 is like a soft mattress cushion. Yeah.
F1 evolves like forever.
Not forever, because they will have some loss, but pretty close. It multiplies the two things that are colliding together. That's why they're between 0 and 1, because yeah. So if the ball is a 1.0 and the floor is a 1.0, yeah, they'll bounce forever, effectively. But if the ball is a 0.5 and the wall is 1.0, then you only have 0.5 bounciness, and it'll slowly, right? Does that make sense? And when you set the shape here, we're going to use the polygon shape. Now, there's a weirdness we're going to use with that polygon shape. Right? So that's the default fixture definition. And then when we go to create the shape itself, the actual shape, we take our new rigid body that we want to create, right? here we need to find our position. Right. Doing things out of order. Vector 2. All about the fun sequence.
Why did 0 there?
You're giving it a width, a height. Why is there a 0 there? I don't know if that's a thickness. I have to look it up in the docs. My old one had a 0 there. And then I'll come back and look at that. I have a note. Hmm? Yeah? A rotation. Yeah.
So 0 would be what?
Angle of rotation.
Oh yeah, but the 0 is by default.
In radians.
Oh, you rate it. Oh, you rate
Yeah. It's not that guy. I'm not going to hang on to it. I was going to pass it back. Have the create wall pass back the wall that it created. I suppose I could. Right. But I need to create it with the world. So this dot model is my world. And then I need to create a body with my body definition. And I need to take that wall body and I need to create a fixture with it. Crazy. You can chain these together. Right, that's usually something we'll do. I wanted to do this as a separate thing because every single rigid body that you create has to follow this formula. You have to create it using the world. Okay, so this is the world controller, so this .model is the world. It also means you're going to need access to the world to create new rigid bodies. So when you create a new rigid body, which I suggest you do by using a class, like your game object class could create its own rigid bodies. But one of the parameters you would pass in is the world. You don't need to access anything other that create the body. So your game object could have a method which is, create rigid body, and it takes the world as the parameter, and the rest of the parameters are in the rest of the game object already. In this case, I return it, but I don't do anything with it because they're walls. And I don't need to hang on to them. I don't need to simulate them or iterate on them. Okay. This is all set up. There's nothing here that's dynamic yet. Okay. The part that makes it dynamic is when we go and add the update and the render part of your world. So the update part, the simulation part, the really important part is we got to take the model, which is a box 2D thing, remember, and we tell it to run one step of the simulation. Now, they've got some funky parameters here. Okay. This is the time slice of a second. Remember, the world is in seconds, not milliseconds. So that's a time slice. Velocity iterations, position iterations. The way it simulates physics is it does a recursive pass through every rigid body. And as it goes through every rigid body, it tries to update their positions based on all the forces on them. But it doesn't just do it once, because otherwise you'd get this ripple effect. One thing would move a huge distance, which would perhaps pass right through something else. You understand? So the way their engine works is you tell it how many steps to go. Now, if you make those numbers radically different than this, like anywhere up to 20, okay, your algorithm, the box 2D world simulation, is going to run very slow because it's going to be super, super precise, and your computer's going to spin for a long, long time, and it'll take longer than a 60th of a second, and bad things will happen. If you make this number too small, like a 1, then you're going to find objects passing through things, right? So as you're moving along, if there's an object here and an object here, what it wants to do is small steps. Did they hit each other? Now, every time they want to test that, realize they have to do what's called a bounding box test. Okay? So a bounding box test, and you can write this yourself at some point, but you really got to take the outer edges and go, is my right edge farther right than this guy's left edge? Is my top taller than his top? Is my bottom lower than his bottom? Is my right? So you got to test each. There's 4 conditions in each way, so it's 8 comparisons you got to do with every other object on the screen. Add 6,000 objects, that's a lot of comparisons to do. Okay? So they do them in little steps. And again, you make those steps too small, 1, 2, they pass right through each other, no collision. 20, they slowly move as it makes recursive iterations, and it gets exponentially worse the more objects you have. So my recommendation with all of this is use those numbers because they'll work. And then the other thing that I think makes the simulation run better now, this might be a little controversial, but this clears all the forces after every frame, every time you call update. Okay, which means you have to reapply forces, which is a little, should you have to do that or not do that? What I would suggest doing is put this in And once you get the first couple things moving and colliding, comment it out and see what happens. Right? Experiment with it. Now we can backtrack. Back up in our main program here, we have an update. What does the update do? This dot world. And you're done. We're doing pretty good, right? We don't have anything to bounce around in the world, and we've only built a floor, which means if we did have something bouncing around, it would hit the floor if it was in the right spot and fall forever. Now, the most common thing that I've seen when people do this project in the past is they forget to put the floors and the walls in, and then the simulation runs really quickly. I loaded my level, the objects appeared and then disappeared right away. Well, yeah, that's exactly right, Jim. They didn't really disappear. They just very quickly moved off screen and didn't collide with anything. This is also what happens if you get the math wrong on where your floor is. Because if it's off screen, you're not going to see much. If you make it and you get the negative sign wrong and your floor is at the very top, right, things are going to just fall forever. So watch out for those kind of typical things. How do I get to see it? Like right now, the simulation's great. Cool. You've got the chunk of code you need to make a rigid body. You need to modify it to fit inside a game object and take the world as a parameter so that you take the rest of the parameters from the game object. You want to be able to build a game object from the level data, just like you generated it. Now you know where the restitution parameters go. You've seen the Box 2D weirdness with creating the body definition, then the fixture definition, then modifying them, and then creating the body later. Right? As long as you get the things in the right order. This is always a weird one to me. I have to set it as a polygon shape and then change the shape. I can't just set it as a box right out of the... Right? When we want to render these things, what do I want to do? Well, to render the world, I need to do nothing. There's nothing to render. Okay. So just to make it complete, and where things might get a little messy, as you create things, you probably want to hang on to a list of the controllers for them. I've done both ways. You can make the list of collidable things inside the world. You can make a list of collidable things inside the main application. If you do it in the main application, what you have to do is, as well as the world update, you'd have to walk through all the entities and tell them to update themselves. In your game object, you make an update method. The update method does nothing in the rigid bodies, by the way, because the world does it all. But just like the render does nothing in the world, the render does everything in the individual game object. Okay. So when you want to draw the actual position of the game object, you're going to do everything you did in your level editor, plus add one more bit of CSS. And that one more bit of CSS is you're going to add a transform. And that transform is going to have two parts to it. It's going to have a translation and a rotation. Now the translation, you need the screen coordinates from the rigid body. And again, the rigid body is represented by the center point of the rigid body. So you need to like convert that to screen coordinates, then figure the offset from the div. Okay, what I'm saying. It'll be a little awkward the first time you do it, but you'll recognize it pretty quick. The other part is the rotation. When you pull it out of box 2D is a little bit weird. It's in radians, and well, the rotation is around the center point in box 2D. And in order to achieve that same rotation on the web, right? So box 2D, it rotates it around the middle point. And then you ask for the rotation and it gives you an angle. And then to rotate a div that same amount around the center point, you either need to change the pivot point or translate, rotate, translate back. Okay? And you can change the pivot point with CSS. So it's a little easier. One other suggestion for you. Where is it? I suggest you in load level. This is where you ask the server for your level data. And this is also where you create new game objects. Right? So and then now for the game objects, you're going to need to update their position on the screen. So I'm going to create a short one that's not going to have everything in it. I'm just going to kind of stub it out. Inside here, you probably want to take in the world controller, okay, and update won't do much, render, right? And I would just propagate this idea so again, when you construct it, you'll do effectively this inside the game object, make a private method that generates the rigid body. It's going to be dynamic instead of static. It's going to have the density restitution that came from your level data, right? And the polygon shape, you can set them as box to start with. Obviously the X, Y, width, height are going to come from your level data as well. Okay? You've had the world pass to you, and the thing you return, you're going to hang on to into the model property. So in your world, if you house them in the world, put in, there's the model. So I would put all my game objects in a list because it's the world that's creating them, right? So the world's load level loads all the collidable bits, and as it loads the collidable bits, it creates a game object for each one. Attach the game object into that list. In that case, this guy's render method starts to be something like now, what method are we going to use to run through all of the objects in the list? You could use for each, and then you got to put a function in there. Right? You can also use map. This is another one. So we haven't really got into processing lists and list stuff. And we'll introduce some more of it, but there's a whole suite of methods attached to arrays in JavaScript that do some rather fancy things, and almost all of them take a function as a parameter that you want to use, like a fat arrow macro to do something. The three most common ones, map, filter, and reduce. So reduce makes a smaller list from a bigger list. So anything that the expression evaluates to true is in the return list. That's filter, right? Reduce does the same thing. One of them operates on stuff, one of them just operates on booleans. And then map applies a consistent function to each item in the list, a lot like for each does. They have some subtle differences. Okay. But I'll get into more of that later. I mean, that's pretty much all you're going to do with them, right? And you could collapse that up once it works. So render becomes really small. And hopefully you're starting to see where I'm going with all this objects and defer your development. You know, that top-down development thing is you don't need to know how to do everything right away. You just start stubbing it out. And short things are really easy to debug. So you keep stubbing it out till you get down to the point where it's short. This guy, for me, this would be too long. I would break that into 1, 2, 3 methods. Because I can parameterize those things. But you can get as fine-grained as you want. That's still not too bad because it fits on one screen. I don't have to scroll to edit it. If I want to go a step further, I can use the outline mode. So I can flip to things really quick. So the tools just help you. Now, when you start off, start with those game objects as well when you get to them, and with those game objects, just take them from your editor to begin with. Okay? If you call them a prefab, make a copy of it, call it a game object. That way, prefab, just CSS stuff, game object, physics stuff is in there too. Right? Cool. I've gone way too long. I've stuffed a bunch of stuff in your brains. And it's time to back away and let you fight with it for a little bit. Right. I'm going to flip repositories and save this, so I'm going to stick around here for a few minutes. I would suggest you get up out of your chairs and clear your brains.